Oh, mine's showing as recording now, yeah.
Yep, mine is showing recording as well. I'm not sure, are we broadcasting yet? Okay, I see in the chat that we are broadcasting. We'll give this one more minute. The start time's at 10:45. So we'll allow some folks to join into the room, and then we'll kick off here right at 10:45. You good with that, Nigel?
Absolutely, mate. I'm excited.
Awesome. All right, so I'm being asked to give us one more minute, Nigel, for more folks to
Yeah,
join
yeah.
into the system. So we'll make it 10:46 when we start. So just give us a moment, folks, and we'll be right into it. You have to love all these new platforms, the new normal, getting used to doing these sort of things. It's not as easy as just standing up in front of a whiteboard in front of 40 or 50 people anymore, is it?
No, I'm going to agree with that. It's very different. But what I will say, Don, is it's still game day, right? And so you still get kind of pumped and excited. You can still connect with people. It's different, but it's all right. I'm getting used to it.
Yeah. The adrenaline rush is definitely still there, that's for sure. Presenting in front of folks is always fun.
Well, do you know
All
what?
right.
My adrenaline rush is less on that, and it's more on how cool I think the technology actually is these days. So, actually, maybe it's the two of them combined.
There you go. And actually, on that note, how about we get started here? We're
Yeah.
just past 10:46. I see we've got a number of participants here. So let's go ahead and kick this thing off. And let's start talking about how Commvault is taking Kubernetes apps to the next level. So my name's Don Foster. I am the VP of Storage Solutions for Commvault. And joining me today is Nigel Poulton. He's an author of the Kubernetes book. He's trained, it says, over 1 million people on containers. I know, Nigel, you and I have discussed Kubernetes, containers, CSI, YAML files a number of times now.
Yeah.
And you've been working with containers specifically for about the last 5 years or so, right?
Oh, mate, longer than I care to remember, to be honest. So I was working with Docker in like the pre 0.9 days where it was like super hard. So we're living in a golden age now where stuff is kind of easy.
Well, that's a big key topic for today on talking about how Commvault's taking Kubernetes apps to the next level, how we help make things a little bit more simplified, how you can kind of bring some of those cool technologies that might be a part of your infrastructure and bring it into this new cloud native world. But before we get into that, I just want to highlight for folks, we've got a number of people with us today. Commvault has been expanding our portfolio. And what we're really going to be talking today is a lot about infrastructure and what that infrastructure can do for you in your Kubernetes world. So as you see in the middle here, you've got the Hedvig multi-protocol storage. That's our software-defined distributed storage platform that has a lot of technologies built into it. And that's going to be our core focus today. But as you see across our portfolio, we have a number of things that we offer in a very integrated fashion, from how we do complete data protection, disaster recovery, our new Hyperscale X, which, by the way, leverages this Hedvig software-defined storage file system to provide that super scalability for where your backup data might reside, all the way to doing data management SaaS, protecting some of the cloud-native applications across some of our, and then of course some of the different applications we have for understanding your file storage setup, doing data governance, e-discovery, compliance, search. We've got a heck of a portfolio that we've continued to expand on. And we're just getting started for how all this can come together to help you drive intelligent data management. But like we said, today's focus is really about Kubernetes, right? Kubernetes, containers, and how this is sort of transformed and where we're taking these applications and how Commvault can help. So knowing that we might have a number of folks, there we go, knowing we might have a number of folks that are across the spectrum on Kubernetes, some that might just be starting their journey, some that might be looking for that next step in this application modernization era. We're going to really spend time on three main things. The first is really talking about Kubernetes and containers in general. And then from that, explaining what Commvault's bringing to the party as far as making things more simplified, more automated, bringing the rigor that you might need as you drive this application modernization journey and start trying to make some of these new Kubernetes apps more production. And then we'll sort of end with how we can get started. And of course, after that, we'll then wrap up with a quick Q&A in a different session. So make sure to join us there if you want to do some live Q&A with us. And we'll have another 15 minutes or so to kind of go through those conversation tracks. So Nigel, you are the expert, although you don't like being called an expert.
No.
But give us some background here on why containers, sort of, where we've come from and where we are today.
Yeah. Cheers, Don. So appreciate the introduction. I'm buzzing actually to be able to talk to everybody here. So thanks for coming, everybody. You mentioned the Q&A session afterwards, Don, as well. There's also like a Q&A chat widget here as well, if anybody wants to interact with us while we're having the conversation here as well. I know you said I'm the author of the Kubernetes book, right? But before getting into Docker and containers, I spent like a long time as a storage expert, and I even wrote a book on storage. So I'm just saying that to kind of provide some background for if I sound like I am overly excited about what we're talking about here, it's because I've got a background in enterprise companies and enterprise applications that work with mission critical data and storage. And to see this actually coming to the Kubernetes and containers party has got me proper buzzing. Anyway, so look,
and we're going to be super techie on this session too. So this is going to be, like I say, it'll fit the whole gamut of the audience.
Oh, I think so, yeah. So look, I get asked the question all the time, what are containers about and do I need to bother about them? And I would say for the second part of that question, do you need to bother about them? The answer, 100% right, absolutely yes. And I quite often frame this in the context of VMware or virtual machines, right? So if you imagine where you were maybe as an individual, but certainly as an organization before virtual machines came along, and it was one physical server to one physical application, and it took ages to order those servers, to rack them, to get the applications on them. And then we kind of wasted all of the resources of the server because most of the time we bought something that was far too big and the application used, I don't know, less than 10% sometimes. So those were kind of, compared to now, they were the dark days. And virtual machines came along and they really forced the needle over to the right in the right direction on quite a few things. And three things I want to talk about or just mention were that speed to market, that ability to sweat your existing corporate assets, servers and things I'm thinking about, and to make your applications more portable. And if you hadn't got on board with virtual machines, where would you be as an individual and where would you be as an organization? And I think, look, the answer to that question is almost always going to be you wouldn't be in a very good place, right? You'd be wasting money and resources and your time to market would be terrible. Well, if we frame containers against those same three things, they push the needle even further. So you can get to market even faster with containers, and who doesn't want that? Containers are more lightweight and efficient than virtual machines as well. So the number of applications you can get per square foot of your infrastructure is much greater as well. Again, those same needles that VMware and virtualization pushed, containers is pushing. And application portability, I mean, that's even better as well. So you get all of the good stuff that you got with virtual machines. You get that, I'm just making this up, right? 2x, 3x, whatever. You just get it much better with containers.
So suffice to say, Nigel, containers and Kubernetes, they're not just a passing fad. This is the future for applications.
Absolutely. In fact, it's already here for a lot of organizations as well. And the writing is on the wall that from the vendors are all bought into it. There's strong community backing. All the different cloud providers are buying into it. So if you're wondering, is this something that I want to lay a bet on for my business and for my career? The writing is all over the wall that this is about as safe a bet as you're going to get. So absolutely, yeah. Now, I want to point out that containers take things a little bit further as well. So let me mention cloud native. It's a loaded term and it means different things to different people. But for me, I consider anything, and I'm talking about infrastructure and applications here, to be cloud native if they self-heal, scale, if they do updates, and if you can deploy them anywhere. And again, couple that with what we just talked about before about speed to market and sweating assets. who doesn't want that whole picture of self-healing and dynamic scaling and deploying anywhere? So containers really bring that, that big long list that we've talked about to you, to your career, and to you as an organization as well. Now, of course, it's not easy making this transition, and we need help managing applications that are running in containers as well. And this is where Kubernetes comes to the plate as what we quite often call the operating system of the cloud. And it's like a buzzword, and you might think, all right, what's this guy talking about? Does that even mean anything? So just think about how like Windows and Linux let you abstract physical server hardware at the low infrastructure layer. You can have Dell, you can have HPE, you can have Cisco, whoever servers you want. But as long as you're running Windows or Linux, you can run your applications on anybody's hardware. And I'm saying that for today's modern infrastructure of like clouds, and I'll just move the slides here, Don. I see it's balked on us. Today's world of clouds and all the different options out there, it can be like, oh, what's the right option for me? So if we look at this slide, right, and we say, look, everything centers around applications. Those 4 icons represent our applications. Then at the bottom, at the low level, we've got like on-prem bare metal, on-prem virtual machines, all these different cloud options. And it's like head spinning, too hard to make the right decision. What we need is something that will come and sit in between our applications and that infrastructure, abstract the infrastructure, but also provide the hooks to our applications to be able to do that self-healing, that scaling, that rolling updates and version rollbacks and things like that. So Kubernetes comes to the party and it says, don't really worry too much about your cloud infrastructure at the bottom or your on-prem infrastructure. I'll abstract it all. Plus, I'll give you all of these sort of hooks that let you do really cool things with your applications. And I use the word cool probably too much because in a business context, these are really valuable things, that dynamic scaling and self-healing and stuff.
And this one slide is just, if you just go back for 1 second,
Yeah.
Great representation of what you really mean by cloud native, in the reality of it, and the OS of the cloud, right? Because in this case, you're abstracting clouds on premises. It doesn't really matter, all for the outcome that the applications themselves require. And this might be leading into the next piece on, hey, what else is missing here? I would argue that there's also an aspect of software infrastructure, or like software-defined storage, software-defined infrastructure, that also fits within that layer underneath as well, especially as we start talking about more stateful applications and applications that need to actually run side by side with some of our traditional apps themselves.
Yeah, for sure. Like we could really stack out that bottom layer there, and it would be littered with the options that you've got. So yeah, Kubernetes comes along and just kind of makes it easier by sitting there and abstracting and arbitrating. But yeah, you're right about cloud native isn't just for public cloud or anything. It definitely includes on-prem and things. Basically, anywhere that you can run Kubernetes, you can run a cloud native app.
That's right.
Now, like, I don't want to take too much time, so I'll just say that like there's loads of cool stuff that's already going on there. But for like your line of business mission critical applications that store business critical data, containers and Kubernetes were really late to the party, to the point where I kind of wondered, are we ever going to see quote unquote enterprise grade storage solutions in the container space? And I started like thinking it's never going to come. But literally recently, I would say 6 months, maybe a little bit more, things have properly ramped up, which is where I think you're going to start telling us a bit more, Don.
Yeah, absolutely. So like, let's talk about then a little bit what Commvault brings to the party, right? So initially when Kubernetes and containers and the Docker world, et cetera, started, it was about essentially the stateless apps, right? The ephemeral applications that you could just light up anywhere, any point in time. There was no real data that came with them, just a small configuration file, and you're good to go. And that worked for a number of different services. But what we've discovered now is as these large monolithic applications start to go through this new modernization, this new modernization effort, application modernization, or whatever the project might be called internal to your organization, we're starting to realize that bits and pieces of these applications are being splintered off and created in containers themselves, in Kubernetes. And of course, they need to have a location to store that data. And so that starts to suddenly change the entire game of what's required to run these new stateful applications, not just have stateless applications. Because now you have a bulk of information that you have to move with the container as it fails over, or as you move it from one location to the next. And of course, development becomes a little bit more challenging. So what is it that Commvault's brought to the party? Undoubtedly, you've heard about Commvault acquiring Hedvig. We had the 1-year anniversary now. We just passed it last week on the announcement of the intent to acquire Hedvig. And yeah, thank you. And with that acquisition, what we essentially acquired was a fantastic software-defined distributed storage platform that allows us to attach to all these new workloads and truly run in a cloud-native or a hybrid cloud way. And the reason that is because what Hedvig essentially is it's a software-defined storage. So almost think of it as your storage infrastructure that can run on any platform. And what we mean by that is it can be on x86 servers, it can run on cloud compute, it can run on cloud compute and cloud storage, it can run on a mix of different infrastructures that can span both on-prem, hybrid, and to the cloud. And what that then gives you from a solution perspective is not only a storage setup that can span multiple data centers, distribute writes, provide the level of resiliency and performance that you need, but it can also ensure that you have this level of availability in a resilient way that's spread across multiple locations and even give you that simple attachment into the cloud. So when you start thinking now about Kubernetes, stateful applications, needing multiple blocks or multiple different protocols for how you want to attach maybe these devices, software-defined storage as a technology is a really easy entry path into providing a truly scalable and cloud-native infrastructure. And then, of course, using Hedvig, we bring a whole lot of interesting new workload components that tie natively into that Kubernetes orchestration environment. And then we're going to talk about that next year. So what we've really been doing, we think about Hedvig, and for the last year or so, there's actually, maybe take a step back, right, Nigel? The most important part here from a Kubernetes perspective is making sure that your storage controls are integrated natively into the Kubernetes orchestration platform, right? The last thing you want to do is have to go out and write multiple third-party scripts or have different sort of workflow tie-ins just to ensure that you are, as a DevOps person, controlling and managing your environment the proper way.
Absolutely, yeah.
Yeah, so there's this thing called CSI, which is Container Storage Interface. And it was primarily developed initially to help create storage classes and drive what are called persistent volume claims. There's a whole lot of other capabilities and support behind that. So a year ago, our devs in the Hedvig team basically started working through that CSI and making sure that we had that native integrated support for our storage to be able to provision, dynamically scale, dynamically resize, provide the security, define exactly what sort of storage class details we want from a tier 1 all the way down to a tier 3, and make those basic needs of attaching a stateful volume or persistent volume directly into the DevOps model natively with Kubernetes. So that was sort of our starting point. From there, we then realized that, okay, not all CSIs are created equal, right? Not all integration that happens from a container storage interface is the same. And so we started to extend that for the cluster itself to ensure that our protection mechanisms are also addressable through the YAML files or through the actual objects that you would code within your Kubernetes clusters. So we took in storage snapshots, created volume snapshot classes, made it simple for you to identify how you'd want to schedule, drive retention, make sure you're meeting different SLA delivery, whether that's just for the DevOps team, for how you're protecting your different development work, creating new branches in your dev tree, or actually bringing these applications into production. And of course, from those snapshots, we even made the ability to clone a snapshot, which in the Hedvig file system is incredibly efficient. There's almost no overhead whatsoever. It's all just software pointers that are connecting us to those points in time. But we're making that capability completely addressable through the Kubernetes platform as a programmable object.
Yeah, Don, do you mind if I just interject real quick? I'm
absolutely.
Just conscious of anybody that's like, spelling Kubernetes is like a challenge for them. And I'm not disrespecting anybody there. I just mean like, if you're like super new to Kubernetes and Don and I are throwing terms like CSI around as if like everybody knows. Just imagine you've got your storage system on the right in a diagram or on the left, let's say, yeah? And then you've got your Kubernetes cluster running your applications over on the right, and you need a way to get like those storage volumes, but not just the volumes, like Don was saying, all of the capability of snaps and replication and that kind of stuff. How do you make that available to your applications? So kind of gluing those two together is the CSI. It's kind of a plug-in layer between Kubernetes and your storage volume. So that's kind of what your infrastructure would look like. And CSI is all about just getting that storage and its features into your cluster. And I loved what you said, Don, that like they're not all created equally, because some CSI drivers just let you provision storage and that's end of story. Whereas we're talking about some pretty advanced features get exposed to our Kubernetes applications.
Absolutely. And in fact, I just kicked over to the next slide as you talked about the CSI. And you know, if you've not seen this before, I mean, it may look a little bit daunting at first, but as a Kubernetes developer kind of gets into how they're executing against their applications, creating their different configuration files, this becomes pretty, you know, to use the term old hat, right? It's kind of an understood example of how you're going to actually put these different applications together. So on the left-hand side is a perfect example, Nigel, of a simple provisioning example of the CSI. Because what you have here is a storage class. And by the way, these storage classes are much like think of it like a tier of storage or a policy that you're defining, right? You define your storage class, you define it with a name, and once you do that, you know that any time that you want to provision a new volume based upon that storage class name, you're going to get all of these parameters dealt to you. So in this case, we're showing that we're doing a Hedvig block volume. It's going to be data center aware, which means I'm replicating data in a resilient fashion across multiple locations. That includes on-premises, AWS, and Google Cloud in this case. And we also have the ability to do this in a tenant space. So almost think of taking your storage array and chopping it up in 4 or 5 or 10 or 1,000 different pieces and giving different tenants or different developers X amount of space or resources they can work from. This is exactly how you can start to define these components. That's a really simple storage class that can be highlighted and that Hedvig enables through our CSI. On the right-hand side, you see a much more advanced CSI that starts to tie in a number of different variables from migration locations, schedule policies, volume expansion, and of course at the bottom here you'll see the exact storage size and what we're doing from a PVC perspective, right, or persistent volume claim perspective. We'll talk about these on the top here in a moment, but just want to highlight exactly, you know, the amount of options and capabilities that suddenly become instantly programmable as you start to work through these new persistent applications. It becomes super easy. You can define your policies or your storage classes, and then you can ensure that those volumes are adhering to exactly what you're looking for, whether it be tier 1 all flash, or maybe it's, you know, more SATA, slower spinning disk tier 3 for a dev environment. We're just doing some basic, you know, test and dev environments.
So Don, just for anybody that like might look at this and it's a bunch of YAML code, and if you've not seen it before, you might be like, gosh, do I really have to learn something like that? And like you said, of course, you know, once you get to work with Kubernetes, this is Kubernetes language at the end of the day, becomes super easy. But I just counted the lines in the storage class over on the left. There's 10 lines, right?
Yep.
But if I draw here, it's these 4 bottom lines, right? So effectively 4 lines of code, and I'm going to get some block storage on my Hedvig array, which I know is enterprise grade storage, right? Anytime so I'll have an application that says, okay, when I spin up, I want, 100 gig of storage, and I'll have it from this SC production class here. Anytime I get storage from that class, I'm getting it from the Hedvig, and it will be replicated to 3 data centers using a data center aware replication policy, and we've got tenanting going on as well. So those 4 bottom lines, I'm getting like amazing enterprise grade stuff. Like, of course, as long as I've got the Hedvig array and the CSI plugin, which is also super simple to do. I just wanted to really stress that, like, don't be put off by this code, because 4 lines there and you are getting, I'm going to be too cheesy here, right? So just excuse me, but like what I dreamt of for the last 3 or 4 years.
You've got it right there, right?
Yeah, absolutely. I mean, it almost couldn't be easier.
So the one thing I will remind folks, and we'll talk about this a little bit later on getting started, of course, you need the Hedvig infrastructure running in the locations that you want this to be operational. And we'll talk about what that means and the different ways of replication and what have you as well. But to your point, I mean, this is cloud native storage. This is driving storage in a software defined way, similar to how the cloud providers give, you know, similar capabilities, right?
Yeah, 100%.
So let's take one more step forward, and then let's talk about some more of these advanced capabilities. That was a fairly basic storage class. So how do we take these advanced capabilities that we just talked about in storage and protection and also make them programmable as well within the CSI itself? Well, so what you look at here is So we've got a create snapshot class. Almost think of that like a storage class for snapshots, i.e. you can set different policies for how long you want to retain them, where they're going to be handled through what the name for that class might be. And that allows you to really program exactly what you want out of a sort of a snapshot retention policy. Below that, you have an ability also to then create a volume snapshot. And so this is essentially calling out what PVC, or persistent volume claim, persistent volume, that you want to snap against, and essentially tying it back to a snapshot class for retention and scheduling, etc. Now, if you look at this here, this actually right here shows an on-demand option for how you would create a snapshot. Because you'll see there's no schedule. You'll see that the actual snapshot class is essentially, delete after its utilization. And so all we're really basically doing is creating a snapshot, and our deletion policy, it's leveraging another policy we're defining as a delete policy, which is essentially create, hold for a number of minutes, and then delete it. So it's very similar to the ways you would think about traditional enterprise storage snapshot management, but we're making it completely programmable as a part of the YAML files and the configuration files you'll put together for Kubernetes. On the right-hand side, then, is what I think is some of the coolest tech that we've expanded, and that is taking a snapshot, cloning it, and then creating a clone as a persistent volume back into a Kubernetes cluster. So here you see there's one more piece here that I didn't show just for the sake of time, but it's actually taking a snapshot and creating a clone, in this case a PVC clone, and then taking that clone and now mounting it back into making it mountable back into a Kubernetes cluster. In this case, making the storage 10 gigs in size. So this is all programmable capabilities that we've now tied in within one Hedvig cluster, these advanced capabilities that would work just as if you were inside the GUI as you are in the actual YAML files themselves. So beyond that, though, Nigel, this is where things really get interesting, especially when you start taking applications to that next level, right?
Yeah.
We didn't just stop with snapshots and clones and the provisioning and the neat things that you can do inside one storage array. We also realized that, look, if applications start to go more towards production, disaster recovery and high availability are a must. From a DevOps team, so when was the last time you talked to a customer, Nigel, and they told you they had one large Kubernetes cluster running in one location that everyone accessed?
Probably never.
So we talk about virtual machine sprawl back in what was like 2005 and 6 when it really started to take off.
Yeah.
I would say Kubernetes cluster sprawl is a real thing too, just like a container sprawl is a real thing, right? So in most organizations, you might have developers working across multiple clouds, multiple instances, multiple Kubernetes versions. That's okay, as long as you can help maintain sort of that development process, the CI/CD process. To do that, especially with stateful applications, you need an ability to migrate from one location to the next. Well, if Hedvig can work in a multi-cloud environment on-prem, we can also, and if we can replicate data from site A to site B, we can start to help synchronize and solve that sort of data gravity challenge so that as you're developing, as you're creating data, as you're validating, etc., that data is automatically being moved for you from site to site. And from a disaster recovery perspective, of course, if we're doing these snapshots, the replication, ensuring data is synchronized, that also means you have a DRHA capability as well. So it's not just about doing snapshots and clones inside of a cluster, but it's also now adding that cross-cluster replication, the really optimized change block tracking that we're doing at a kernel level inside our software-defined storage, and the ability to go one-to-one or one-to-many and keep these things synchronized. It's going to really help speed your DevOps process, but then also give you that level of high availability and the rigor that you might need as you start to bring these applications to production. So what does that look like? Again, a little bit more CSI. What this essentially looks like, and this goes back to the first sort of, there's probably 25 lines of code that we had shown before, right? So you might have remembered seeing the actual migration location. So here we have a migration location, which is actually saying, I want to replicate from Hedvig cluster 1 to 2. And in this case, I'm choosing a dev cluster that's going to be running in Azure. Now, here's the beautiful thing about naming this location. Once you create a volume that is tied into this replication location, we're going to automatically create the target volume for you at the secondary side. You'll also see that on the snapshot scheduling, we're adding in intervals for scheduling and retention. So in this case, I'm going to make sure I always have 2 snapshots available. And on top of those 2 snapshots, I'll be creating them every hour. And that every hour creation period will drive the replication that will go from on-premises or my production location to the secondary side. And using that change block tracking will make sure that data movement occurs. And of course, finally, when you think about how you tie these together, if you see here, again, we've got our storage class. Our storage class is called SC Hedvig Migration. So we know we want it to be a migration storage class. We know it's block. We want to turn migration enabled. So that variable ties into this. The location name obviously calls out that policy for how we're going to be or where we're going to be migrating. And then our schedule obviously flows here. And that's how all these come together to make these advanced capabilities instantly available inside of your storage.
Don, just as well, again, like it's more Kubernetes YAML code and it can look scary, but just from somebody who's worked with Kubernetes for a long time, to see the way that you're doing this, so my marker is the black marker, but here, you know, these lines up here, it might not mean anything to a lot of people, and these lines down here, but they show how Commvault has been extending the Kubernetes API to make all of its advanced features that we're talking about here, migrations and snapshot intervals and things like that, they look, smell, and feel like they're Kubernetes native objects. So once you get into Kubernetes and you learn Kubernetes, because like that's the DevOps tool going forward, hooking a Hedvig storage solution in is like, it just looks like it's native Kubernetes at the end of the day. You're not like having to learn something new or run those complex scripts that maybe you mentioned earlier, Don. It's a really slick solution.
And that's really been our goal, to make sure that this looks as native to Kubernetes as absolutely possible. If we are forcing a dev person, a DevOps person, or even a storage infrastructure person to go into a storage console every time they need to do something for their application modernization team, then it's done the wrong way. It needs to be integral and integrated and something that anyone can just write some code, give them some resources so they have boundaries from what they're working from, and they're off and running. So what does this entire workflow kind of look like? So let's imagine we have Hedvig running in AWS, Google, Azure, and other on-premise locations, as well as on our production site here on the far left. To your point, Nigel, there's Kubernetes running everywhere, and we need to have this linkage that ties storage to these new stateful apps, and then ensure that we're taking that storage and replicating it to all the different locations that we might have developers or production code running. The way this whole workflow works, we have Hedvig delivering Kubernetes persistent volumes. We integrate in those persistent volume snapshots to provide that protection. Maybe it's every minute, replicating every minute. Maybe it's every hour. It's up to you and your development team to define that SLA. We then use the intelligence in our software-defined storage platform to ensure not only are the volumes consistent when the snapshot gets created, but then we do the proper differencing to know what blocks have actually changed inside the system to keep that transmission, the data payload, as small and as efficient as possible. And then we replicate it to whatever your chosen location is, be it to another on-premises spot or to any of the other cloud environments where we are then presenting those same volumes back to their Kubernetes platform that they might be running. It's simple. It's all completely integrated. You've got that smart data movement that you're expecting, and it truly is infrastructure agnostic in a way that's secure and that can run anywhere. So that's essentially the workflow. And of course, it can be reversed back the other direction. We can go from cloud back to on-prem. And in fact, in the containers world, you might find that in most cases, DR is on-premises and production starting to be run on the cloud.
Yeah.
So Nigel, I'm curious, what's your take on going through all of these advanced capabilities? Obviously as the Commvault Hedvig guy, I view this as one of the most industry simple and complete solutions, not only for the IT infrastructure folks that are trying to support the new app dev folks, but also for the DevOps team that's out there just trying to work their day-by-day jobs. What's your take on this?
Yeah, no, Don, I agree. I think I've said already that I think your CSI implementation is feature rich. It's not just provisioning. You're giving us a load of rich features with it. The way you've extended the Kubernetes API is 100% the right way to go about it. So I think that the solution is great. And you know what? We have this thing in the UK called London bus syndrome, where like you're standing waiting for a bus and there's no buses come for ages and then they all come at the same time. And it feels like that's what you've done for me here. So I've been like a Kubernetes stroke storage guy for a long time, like waiting for this kind of enterprise grade advanced storage stuff to come to the party. And it's like, yeah, it's not here, it's not here, it's not here. And then instead of coming and saying, okay, you can now provision storage from a Hedvig into your Kubernetes cluster for your applications, we'll give you the whole lot, right? You'll get the snaps, you'll get the replication, the migrations, you'll get the whole lot. And I'm kind of like a kid in a sweet shop or a candy store where I'm like, oh my goodness, like, where do I start? I know, look, I probably sound a little bit like I'm a shill when I'm saying that, but I'm genuine about this. Like, I am a former storage guy, and I love technology, and I've worked with containers and Kubernetes for ages. And I genuinely have been like, gosh, we are being slow to bring this enterprise storage stuff to the party. But now that it is here, this is a really slick solution. I'm pumped.
Cool. So I know we've got some questions coming through, and let's see if we can do these in the Q&A. I know we're running about 4 minutes over, but to your point, where can you get started? So, Hedvig can run on premises, it can run in the cloud, it can run in the mix of both. You can have this set up in a way where your data center is extending into the cloud, or you could have separate clusters that you manage on premises that you manage in different cloud environments, even at a service provider location, etc. So the place to get started, you could very easily get started in the cloud and start providing some storage capabilities for some of the cloud-driven Kubernetes environments, if that's where your developers are running. If your developers are working off of like a VMware Tanzu environment, we can work with that as well. So it really boils down to where and how you want to get started, and we can help architect or provide the right solution to get that plugin going, get you comfortable with some of these advanced features and capabilities, and then of course expand that as your journey expands and as your needs for these stateful applications continue. So I know we've got a couple of questions here. How about we do this? We'll see if we can capture some of the questions here from the chat, and we'll see if we can start answering those in the Q&A session that we have about 10 minutes for. Does that make sense?
Makes
so
sense
we can have
to me, mate, yeah.
everyone join us in the Q&A session, and we'll get it ready to go.
Cool.
See you there.
Yeah.